Very good morning, students. Welcome back to the combination classes. So yesterday, few of the students were asking regarding the property or the theorem 6. So just explain it once again. So we shall start with the theorem and then proceed to the remaining exercise problems. Okay. And I hope so you are studying regularly, students. Okay. So either it may be any subject and particularly mathematics. Be in touch regularly, then only you will understand the things and you won't forget the things. Okay, so be in touch regularly, it will be very easy for you. Okay, so now the property tells us NCR plus NCR minus 1. So what's the property? NCR plus NCR minus 1 equal to n plus 1 CR. Okay, so now we need to prove left hand side is equal to right hand side. Is that clear, students? We need to prove left hand side equal to right hand side. It's already a proven one. Just we need to establish for ourselves, okay, for our understanding. So let me take the left hand side and keep on solving until I arrive at the right hand side. Okay. So now if so there is a chance, right, to know what's the value of the right hand side before itself, right? Because we know that it is nothing but a combination formula. And what is the combination formula, students? NCR equal to n factorial by r factorial into n minus r factorial. Okay, so is that clear? So just keep recalling the formulas, it will be easier. So now nothing has changed, just in place of n it is n plus 1. Okay, so wherever n is there you need to replace by n plus 1. That's it. Okay, so now let us see what's our right hand side. So n plus 1 CR is equal to n plus 1 whole factorial whole divided by r factorial into n minus r. So what is n here? N plus 1, students, minus r whole factorial. So now let's simplify the left hand side and see whether we get the answer or not. Okay, so now we have NCR plus NCR minus 1 is equal to, let's keep on simplifying for the left hand side. So what is NCR, students? N factorial by r factorial into n minus r factorial plus n factorial by, okay, n factorial by r factorial. So in place of r it is now r minus 1. So r minus 1 whole factorial, okay, into n minus r. So n minus of r. It's not just r here, r minus 1. So keep it in bracket because otherwise the multiplication, sorry, because of this negative sign, you may end up doing wrong. Okay, so is that clear? Is equal to n factorial r factorial n minus r factorial. Okay, so I have to keep in mind of the right hand side value also, keep in mind of the right hand side or value also, so that you can keep on simplifying on the left hand side and keep looking at the answer simultaneously. What you need to get? So n plus 1 CR, you need to get it in this form. Okay, so if this form appears, then it's nothing but n plus 1 CR. Okay, so plus n factorial by r minus 1 factorial. So can I multiply negative here inside? Minus r plus 1 whole factorial. Okay, so now if you observe, so can I further simplify r factorial as r into r minus 1 factorial? Okay, we have been applying the definition of factorial notation, okay, from since long back. Okay, so what is the factorial notation? Right, so definition of factorial notation is product of first and natural numbers, and I have told you while solving the problems, use in the descending order, it will be easier. Okay, so 4 factorial means 1 into 2 into 3 into 4. So but I'll write it as 4 into 3 into 2 into 1, both are one and the same. Okay, so 4 factorial starts with 4 and it keeps on reducing it by 1 till 1. Okay, or if for the problems sometimes you may require in this manner also. So can I say 4 factorial is 4 into 3 factorial? Yes, definitely. Okay, I have written here r into r minus 1 factorial because on the other side I see there is one r minus 1 factorial, which will help us in some way or the other, okay, by taking common. So now n minus r factorial I'll keep as it is, plus n factorial by r minus 1 factorial as it is. Now I'll apply the factorial definition over here, because when you, okay, factorial, it starts with this term, right? So look here, 5 factorial, it starts with 5 into 4 into 3 into 2 into 1, or 5 into 4 factorial. Okay, students. So now n minus r plus 1 starts with n minus r plus 1, get reduced by 1 in the next term. So reduced by 1 means subtract 1. So plus 1 was there. So subtracting 1. Plus 1 minus 1 get cancels. So now it is n minus r factorial. Is that clear? So now you can see this term and this term has some common terms, okay, or some like terms. You can take them common. So n factorial on the denominator, sorry, numerator, and in the denominator I can take r minus 1 factorial into n minus r factorial. Okay, so now n factorial is outside, r minus 1 factorial is also taken as common, r n minus r factorial is also taken common. So in the first term only left is 1 by r, and in the second term 1 divided by, this is outside the bracket common and this is also taken as common. So what we are left with, n minus r plus 1. Is that clear? So now this is a fraction. So fractions means use LCM. Okay. By using the help of LCM, you can write down the, simplify this further. Okay. So let's suppose we have 1 by a plus 1 by b. So what will be the LCM of these? Okay. It will be the product of the denominator, right? Okay. So the LCM is nothing but AB. So now what should I multiply with 1 here? Okay, what should I multiply with? So a, so it should be multiplied here, so that I'll get my LCM b. Okay, sorry, LCM is ab. So what should I multiply a with, so that I'll get my LCM, that is b. And here what you should multiply a, so it will be b plus a. So using this idea only, we simplify this further. Okay. So let me erase this. So what was our left hand side? NCR plus NCR minus 1. NCR plus NCR minus 1. So which is equal to, from here students. So n factorial by r factorial into n minus r factorial. Okay, so now simplify the fractions. So LCM will be r into n minus r plus 1, right? So now, so LCM is r into n minus r plus 1. So we have r here. So what should be multiplied, so that I'll get my LCM, n minus r plus 1. So n minus r plus 1, right? So we have a plus over here. And what should I multiply here, so that I'll get r into n minus r plus 1? So that is r, right? So which is equal to n factorial by r factorial into n minus r factorial. Okay, students. So minus r plus r get cancels. So what is left now? N plus 1 into r, n minus r plus 1. Okay. So now we are done with the simplification. Okay. So now just now I have told you. So 5 factorial is nothing but 5 into 4 factorial, right? And 6 factorial will be 6 into 5 factorial, and 4 factorial will be 4 into 3 factorial, right? So it's nothing but 4 plus 1, right? And this is nothing but 3 plus 1, and this is nothing but 5 plus 1. So now if you observe here carefully, in the denominator n plus 1 into n factorial, we need here n plus 1 factorial. So n plus 1 factorial, how will you write it? Okay, by one step. So n plus 1 factorial, apply the definition of factorial notation. So n plus 1 factorial, can I write it as, and it begins with n plus 1 and get reduced by 1, n into, sorry, n plus 1 into n plus 1 minus 1 factorial. So what is 1 minus 1? 0 get cancels. So I am left with n plus 1 into n factorial. So look here, n factorial into n plus 1 is n plus 1 factorial, whole divided by, whole divided by. Okay, so now just a minute. The common terms are r minus 1 factorial, students. Sorry. So the common term is r minus 1 factorial. Okay, just correct it. Look here. So n factorial by r minus 1 factorial into n minus r factorial. Okay. R minus 1 factorial n minus r factorial. Okay, this was the term, right? So I had written r factorial. Just correct it. Now look here. R into r minus 1 factorial. So can I write this r factorial as r into, so it reduces by 1, r minus 1, I'll stop there itself. So r into r minus 1 factorial is, r into r minus 1 factorial is r factorial. Okay, so now n plus 1 minus r factorial, how you can write it? So n plus 1 minus r, it get it reduced by 1, n plus 1 minus r minus 1 factorial. So plus 1 minus 1 get cancels, right? So what we are left with, n minus r factorial. So now look here, n minus r factorial into n minus r plus 1. So what will I get? N minus r plus 1 factorial. Okay, this into this, I got n plus 1 factorial, right? And then this r minus 1 into r minus 1 factorial into r, I got r factorial, and n minus r plus 1 into n minus r factorial, I got n minus r plus 1 by the idea of factorial notation. Okay, so now I got my right hand side. And what was that? N plus 1 factorial by r factorial into n plus 1 minus r factorial, which is equal to nothing but n plus 1 CR, which is equal to n plus 1 CR. Okay, so hence the proof, NCR plus NCR minus 1 equal to n plus 1 CR. Okay, now this completes the proof. Hope you have understood now, students. Okay. Now we shall see next problem. Don't worry, just keep on practicing. Okay, you will get the idea of using factorial notation. You need to keep on practicing, then only you will get a master over it. Okay, so now exercise 7.4. Exercise 7.4, second question, second bit I have given you it as homework. Okay, and most of the students have replied the answer in the doubt session itself yesterday. So let us see that homework problem at the end. So let's start with the question number 3. Exercise 7.4, question number 3. How many chords can be drawn through 21 points on a circle. 21 points on a circle. So what is the question, students? How many chords can be drawn from 21 points on a circle? From 21 points on a circle. So what do you mean by chord, students? So just recall your high school. So chord is nothing but, okay, so this is our circle. Okay, so chord is nothing but a line segment connecting 2 points on the circle's circumference. Okay, so connecting any 2 points on the circle's circumference. Okay, if it crosses, okay, if it cuts the circumference, it's nothing but a secant. Is that clear? So if it touches the 2 points on the circle circumference, a line segment, it's nothing but a chord. So this is also a chord, right? So how many such chords can be drawn through 21 points on a circle? This is the question, students. So now look here. This is a line segment, right? Chord is nothing but a line segment. Okay. So at the end, it has 2 points. Okay. So now look here. I'll just name it. AB is a chord. Okay. So I'll say AB is a chord is same as saying B is a chord, right? So does the order matter here, students? Okay, does AB chord is different from BA chord? No, right? So here the line segment AB is same as the line segment BA. So it doesn't matter much here. So what is it? What I am talking about? Order doesn't matter here. So order doesn't matter means you have to use selection. Selection means combination. Is that clear, students? Okay. So this is how you break down the problems and try to understand whether they are asking you a combination problem or a selection problem. Okay, so chord is nothing but just a line segment, right? So line segment whose endpoints both lie on a circle, right? So now to draw a chord, how many points do we need, students? To draw a chord, how many points do we need? Two, right? So 2 points will give you 2 points will give you a chord. So out of 21 points, you have to take two at a time. Is that clear? Out of 21 points, you have to take two at a time. Okay. So if this is our chord, right? So to form this chord, we need 2 points, right? So among the 21 points, we need 2 points at a time to draw a chord. Is that clear? So write down the solution. We can get a chord. This is understanding. We can get a chord by joining any 2 points by joining any 2 points by joining any 2 points on the circle. So how many points are there, students? Here n equal to 21. 21 points. So does order matter here? No, order does not matter. Order does not matter. Okay, so we can make a chord by joining any 2 points, right? So out of 21 points, how many ways are there in which you can form a chord? 21 C2. Okay, taking 2 points out of 21 points. So in this way it can be done. So what's the formula of NCR? N factorial by R factorial into n minus 1 factorial. So 21 factorial by 2 factorial into 21 minus 2 factorial. Okay. So what is 21 factorial? Let it be as it is. So 2 factorial, can I write it as just 2? 2 into 21 minus 2. What's the answer, students? 19 factorial. So 21 factorial, can I write it as 21 into 20 into 19 factorial divided by 2 into 19 factorial. Okay, so 19 factorial get cancelled, students. Is that clear? So 2 ones are 2 tens are. So 21 into 10. So there are 2 10 chords. Okay, you can draw 2 10 chords out of the given 21 points. Is that clear? So next, fourth question. Fourth question. Okay, the fourth question is question number 4. Question number 4. In how many ways in how many ways in how many ways can a team of 3 boys and 3 girls, 3 boys and 3 girls be selected from from 5 boys from 5 boys and 4 girls? Okay, in how many ways can a team of can a team of 3 boys and 3 girls be selected? So here they are given it as selection, so definitely it will be a combination only, but try to understand the question also. They are just asking us to pick 3 boys and 3 girls from a collection of 5 boys and 4 girls. So just they are asking us to select. Okay, they are not asking anything further. Okay, so by this we can understand it's a case of permutation. So in how many ways can a team, can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? Okay, so the solution will be, so there are how many boys and 4 girls? Sorry, there are 5 boys and 4 girls. So you need to make a team consisting of 3 boys and 3 girls. So three boys, 3 boys out of how many students? Out of 5 boys. 5 boys can be selected in how many ways? So you are selecting 3 out of 5. Okay, is the team complete? Is the event complete? No, right? The team is consisting of 3 boys and girls. So till now what we have done? We have only picked boys students. Okay, and I have to pick girls only. Then girls also. Then only a team will be ready. The question here is the team consists of 3 boys and 3 girls. Is that clear? So this is just one part of the event. The work is not completed yet. The work will be completed only when girls are also picked. Okay, so a team will be formed only when 3 boys and also 3 girls are picked. So and here indicates multiplication rule. Okay, just concentrate on what is being told or what the question is over here. Okay, so out of 4 girls, out of 4 girls can be selected in 4C3 ways. Okay, 4C3 ways. Hence, by multiplication rule, hence by multiplication rule, hence by multiplication rule. So total number of ways in which you can pick the team is 5C3 into 4C3. Is that clear? So now just simplify, students, and you'll get the answer. Okay, so when you solve this, definitely you'll get a answer. But is there any way we can reduce our simplification? So I have told you, okay, just learn. These are some small tweaks which will help you in reducing your time. Okay, that's it. Or else directly you can use NCR formula, n factorial by n minus r factorial into r factorial. Okay, but we have a property also, right? NCR is equal to NC n minus r. So now can I tweak this as 5C3 is equal to 5C, 5C. N is what is N? 5, right? So NCR. So what is N here? 5. So what is R here? 3, right? So NC n minus R, 5C 5 minus n minus r, 5 minus 3. So can I write this as 5c2? So this 5c3 is same as 5c2. So can I write 5c2 here into, okay, 4c3? So 4c3. So what is n here? 4. What is r here? 3. So can I write this as nc n minus r? So 4 minus 3. So what is 4 minus 3, students? 1. So 4c3 is same as 4c1. At least you can solve this one very quickly. What is 4c1, students? 4. That's it, right? How easily we have solved. You can solve 5c3 into 4c3 also. You will get the same answer only. And haven't used anything, okay, magic over here. We have a property. We have seen this one. Okay, so NCR is equal to NC n minus R. So now, so what was 5c3 into 4c3? So using the property, so 5c3 I tweaked it to 5c2 and 4c3 I have done it to 4c1 using properties only. Okay, so using NCR is equal to NC n minus R. So 5c2, students, 5 factorial by 2 factorial, n minus R, 5 minus 2, 3 factorial. So 4c1 need not simplify. We know nc1 is equal to n. Okay. So now 5 factorial, can I write it as 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial, right? So into 4. So 3 factorial get cancels, right? So 2 factorial, can I write it as just 2? So it will be, so 2 ones are 2 twos are 5 twos are 10, 10 fours are 40. You can check the answer, students. The answer is 40. Okay, so if for your satisfaction, you can solve this and also check. From here also you can solve it and check whether the answer is correct or not. Okay, let me do that just for you to convince it more. Wherever necessary, use some properties or the formulas which we have discussed. So what we used here, NCR is equal to NC n minus R. Okay, so let me solve this only and see. So it is 5 factorial by 3 factorial, 5 minus 3 whole factorial into 4 factorial by 3 factorial, 4 minus 3 factorial. Okay, so what is 5 factorial? So let me write it as it is. So 3 factorial. 5 minus 3 is 2 factorial into 4 factorial. Whole divided by 3 factorial. 4 minus 3 is 1 factorial. So can I write 5 factorial as 5 into 4 into 3 factorial into 2 factorial. 1 factorial is 1. 4 factorial, I will write it as 4 into 3 factorial. Right. So now see, can I deduce 3 factorial and 3 factorial? Okay, students. And here also 3 factorial and 3 factorial. And can I write 2 factorial as, okay, let me write once again, 5 into 4 into 4 whole divided by 2 factorial. So 2 factorial is nothing but 2. 2 ones are 2 twos are 5 twos are 10, 10 fours are 40. Okay, you got the same answers itself. So why not use the properties or the formulas which we know and just reduce the time? Okay, so from here also you can solve it, or you can use NCR. So wherever necessary, okay, NCR n minus r, right? So I reduced it to this form and simplified. Again, I got the simplification as 40. Okay, so it doesn't matter, either solve this or either tweak it to this formula and solve. Both are one and the same, don't worry. So now moving on to the next question. The next question is find the number of ways. Find the number of ways of selecting. Question number 5. Find the number of ways. Find the number of ways. Number of ways of selecting 9 balls from 6 red balls, comma 5 white balls, 5 white balls and 5 blue balls, 5 blue balls. If each selection consists of 3 balls of each color, 3 balls of each color. So what is the question, students? Find the number of ways. Find the number of ways of selecting 9 balls. So you need to select 9 balls. Okay. So from 6 red balls, 5 white balls and 5 blue balls. If each selection consists of 3 balls from each color. So from each color you have to take compulsorily 3 balls from each color. That means from red balls you have to pick 3, from white balls you have to pick 3, and from blue balls also you have to pick 3. Is that clear? And get a collection of 9 balls. Okay, so these 9 balls you have to select in such a way that 3 are from red balls, 3 are from white balls and 3 are from blue balls. Is that clear, students? Okay, so from each color you need to pick 3 and make a 9 balls. Okay, you have to pick a 9 balls. Okay, so how will you do that, student? How can we do that? 3 balls from 6 red balls. So can be selected in how many ways? 6C3 ways. How many ways? 6C3 ways. Okay, and still our work is not completed. Okay, the work is still in progress. If the work is still in progress and I have to do some other job also to complete this work, total work. So that means it's nothing but a multiplication rule. So 3 balls from 6 red balls. The condition why I have taken only 3 balls, because 3 balls of each color. So from every color I have to pick 3 balls. Okay. So now similarly 3 balls from 5 white balls. From 5 white balls can be selected in how many ways, students? 5C3 ways. 5C3 ways. Is that clear? So now and so still the work is not complete. I have to pick 9 balls. So till now how many I have picked? 3 from red, 3 from white. So only 6 balls I have picked still. Is that clear? So still the work is to be completed. They are telling take 3 balls from each color. So I have just picked red balls, white balls. Still blue balls are remaining. So the work is still in the process, and I have to pick the blue balls also. Then only the work will be done. So 3 balls from 5 blue balls can be selected in 5C3 ways. Okay, so now you understood it's nothing but a multiplication principle, right? First you pick any color and you have to pick the other one and the other one, then only the work is completed. So I'm talking here and so it's nothing but a multiplication principle. So the total number of ways in which you can pick 9 balls with the condition that 3 balls are from each color is 6C3 into 5C3 into 5C3. Okay, so let me see if we can use NCR is equal to NC n minus R property here. So NCR 6C3. So NC n minus R 6C 6 minus 3. So 6C 6 minus 3. Okay, which property I have used? NCR is equal to NC n minus R. So 6 minus 3 will give you again 3 only. So no need of it doesn't matter if you apply the formula to the 6C3 or not. Okay, is that clear? So that's why I'll keep it as it is 6C3. So can I write this as 5C2 into 5C2? Why I used since NCR is equal to NC n minus R. So what is n here? 5. C, what is R? 3, which is equal to what is n? 5. C, 5 minus 3. So what is 5 minus 3, students? 5 minus 3 is 2. Okay, so 5 minus 3 is 2. Okay, so you can solve in this manner also, or you can solve in this manner also. Okay, so just wherever necessary you can take the help. So let me simplify. So 6C3, 6 factorial by 3 factorial n minus r. 6 minus 3 is 3 factorial into 5C2, 5 factorial by 2 factorial into 5 minus 2, 3 factorial into 5C2, right? So 5C2 again, 5 factorial by 2 factorial into 3 factorial, right? 6, 5 into 4 into 3 factorial divided by 3 factorial into 3 factorial plus 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. So 5 factorial, can I write it as? So 5 factorial, can I write it as 5 into 4 into 3 factorial divided by 5 into, sorry, 2 factorial into 3 factorial, right? So this term cancels, right? So what is 3 factorial? So let me write once again, 6 into 5 into 4, 3 factorial, can I write it as 3 into 2 into 1 plus this get cancels, 5 into 4 by 2 factorial, 2 factorial is 2. Okay, sorry, multiplication principle into, so 3 factorial, 3 factorial, so 5 into 4 by 2. Okay, so 3 2s are 6, right? 6 into 1, 6. This get cancels, 5 4s are 20, 2 1s are 2 2s are 5 2s are 10, 2 1s are 2 2s are 10, right? So this will be 200 into 10, 2000. So there are 2000 ways in which you can pick 9 balls from red, blue, and so one more was white balls. Okay, in a such a way that every color has 3 balls. Okay. So now next question. So the next question is sixth one. Determine the number of 5 card combinations. Determine the number of 5 card combinations. 5 card combinations out of a deck of 52 cards. 52 cards. If there is exactly one ace, if there is exactly one ace in each combination, if there is exactly one ace in each combination. Okay, the question tells here, the question is how many, sorry, determine the number of 5 card combinations out of a deck of 52 cards, out of a deck of 52 cards, if there is exactly one ace in each combination. So you have to make a combination or a selection of 5 cards, students. Okay, you have to make a combination of 5 cards. Is that clear? So before that, just let me remind you what we have done yesterday. So how many cards are present in a deck? 52 playing cards, right? So these are further subdivided on the basis of color, black and red. Is that clear? So black contain 26 cards and red contain 26 cards, right? So this black is further subdivided into two more suits, right? So what was it? Club, and this is spade, right? And here there were two more divisions, that is diamond, and heart, right? So they are equally divided. So club comprised 13 and here also 13, diamond, heart 13. So how these 13 were reduced, students? One was ace card, so in every way there will be one ace, right? Now next were numbered cards, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now next, what was the card? Queen, king, jack. Okay, now count, students, whether they are 13 or no, right? This is 1, so these are 9, so 10, 11, 12, 13. Is that clear, students? Okay, so now just take a look at it, you will understand the question properly. Okay, so the same thing will be present here also. Ace from 2 to 10, then queen, king, jack, and here also ace from 2 to 10, then queen, king, jack, here also same. But here we are talking, the question is regarding only ace. Okay, and they are just telling ace, and particularly they didn't mention even from black or red or from diamond or heart or club or spade. Okay, so the question is you have to make a, so you have to make a 5 card combination out of a deck of 52 cards, right? So from 52 cards you have to make a 5 card combination. Okay, with the condition if there is exactly one ace, okay, there is exactly one ace in each combination. So you have to pick, so to pick among this five, one must be compulsorily ace, right? So ace, how many ace are there? 1, 2, 3, 4. Is that clear? So 4 ace taken one at a time, exactly once only we can use. I cannot write, or I cannot take ace again. I cannot take ace again. I have to use ace only once. They are talking about taking ace only once. So that means the remaining four places I cannot take ace, right? Is that clear? So how many are there? 52, right? So all the aces you have to take 4C1. It has to be taken here only or at one place, any place. Okay, and I have to fill the remaining also because it is a combination of 5 cards. Is that clear? It's a combination of 5 cards. So among that, one card has to be compulsorily ace. So how can you do that? There are 4 aces taken one at a time, and remaining 4 you have to fill other than ace. So in 52, how many aces are there? 4 aces. So how many cards we are left with? 48, right? So 48, and those have to be filled among how many places? 4 places, right? Is that clear? Okay, so now there are 52 playing cards and exactly one ace must be in that combination. So among the 5, so at least only at one place you have to take ace. You have to use ace only once, right? So how many aces are there? 4. So 4 taking one at a time. Okay. So now in the remaining positions you cannot take ace. right? So among the 52 playing cards, how many aces are there? 4. So remove all the 4 aces. So how many are left with? 48. So these 42 can be taken 4 at a time because still there are 4 places left. So the total number of ways in which one ace is possible with the 5 card combination is 4C1 into 48C4. Okay. So the total number of ways is equal to 4C1 into 48C4. Okay, so now 4C1 is 4 students because NC1 property we have seen NC1 is equal to N. So 48C4, 48 factorial. If you apply here, okay, it won't help you NCR, NC, N minus R. It will be 48C, 44, right? So now 48 factorial, right? So divided by R factorial into N minus R factorial, which is equal to 4 into. So 48 factorial divided by 4 factorial. Okay, don't be in a hurry. This is number 4 and this is factorial 4. In a hurry, okay, you may cancel it. Be careful. So 44 factorial. Okay, so 4 into 48 factorial. Can I write it as 48, 47 into 46 into 45 into 44 factorial. I'll stop here itself. Okay, because we have a 44 factorial in the denominator, right? So now in the next step, can I cancel 48 factorial? Sorry, 44 factorial, sorry. So now the next step will be 4 into 48, 47, 46 into 45. So what is 4 factorial, students? 4 into 3 into 2 into 1. Okay, so just simplify this. The answer you will get is 778320 base. Okay, students. Okay, so 4 get cancels, right? 3 2 6 6 ones are 6 8s are 48. Okay, so now multiply the remaining terms, you will get it as 778320 base. Okay, so we shall solve the next problem. Okay, the next problem, question number 7, we shall solve tomorrow. Okay, 7 and 9. So 8th one, you see, we shall solve a small, very easy one, and then 7, 9 we shall solve tomorrow. Question number 8, a bag contains 5 black and 6 red balls. A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. 3 red balls can be selected. The question is, a bag contains 5 black and 6 red balls. So determine the number of ways in which 2 black and 3 red balls can be selected. So out of the collection of 5 black, okay, 5 black balls and 6 red balls. 6 red balls. Okay, so what they are asking, pick or choose in such a way that you will choose two black and three red balls from this bag. Okay, so how it can be done? So two black balls can be selected out of how many? Five black balls. Okay, so what is the number of ways in which you can do it? 5C2 ways. Okay, so now the next one. Next is you have to pick a three red balls. So the event is still going on. You need not stop here. What they are saying, you have to pick a black ball and a red ball also. So the work is still under progress. Okay, after picking black balls and I have to pick the red balls, then only my work is completed. So that means multiplication rule. So three red balls can be selected out of six red balls in 6C3 ways. Okay, so hence total number of ways, is equal to, by multiplication principle, 5C2 into 6C3. Okay, so just simplify, students. So let's see what will be the answer. Okay, so let me simplify. 5C3, 5C2. Okay, it's 5C2 into 6C3. So use the formula 5 factorial by 2 factorial. 5 minus 2 will give you 3 factorial into 6 factorial by 3 factorial. 6 minus 3, 3 factorial. Okay, I've used NCR formula. So now let's simplify it further. 5 into 4 into 3 factorial. So 2 factorial is 2, 3 factorial into 6 into 5 into 4 into 3 factorial. Right. So divided by 3 factorial is nothing but 3 into 2 into 1. So 1 3 factorial I will keep as it is. So 3 factorial in the next step get cancels. Okay, here you can see 3 factorial get cancels, right? And 3 twos are 6. So 6 and 1 6 get cancels. Okay, so what we are left with? 5 into, so 5 into 4 into 5 into 4 divided by 2. So 2 ones are 2 twos are, right, students? So 5 fours are 20, 5 twos are 10. So the answer is 200 ways in which you can do the work assigned here. Okay, so thank you, students. So it is in the ratio form, right? A is to B can be written as A by B. So 2nc3 divided by nc3 equal to 11 into 1. So now let me solve this one using the formula 2n factorial whole divided by, right? So what's the NCR formula? N factorial by R factorial into n minus R factorial. So what is R in the numerator? 3 factorial, right? R factorial 2n minus 3 factorial, right? So whole divided by n factorial divided by 3 factorial into n minus r. So what is n minus r? N minus 3 factorial, which is equal to 11 by 1. Okay, students. So now, can I write this one as 2n factorial whole divided by 3 factorial into 2n minus 3 factorial into n factorial by 3 factorial into n minus 3 factorial, which is equal to 11 by 1. Okay, so let me solve. Okay, sorry. So it's in the form of a by b whole divided by c by d. So which can be simplified as a by b into d by c. Okay, so I missed that one. So now n factorial by 3 factorial into n minus 3 factorial. So 3 factorial n minus 3 factorial whole divided by n factorial. Okay, so now just look at the terms and keep on simplifying. So we have a 2n factorial and a 2n minus 3 factorial. 2n factorial divided by 3 factorial. So let me simplify the numerator. 2n factorial as 2n. So apply the definition of factorial notation. So 2n, 2n minus 1, 2n minus 2, so on up to 2n minus 3 whole factorial. Okay, stop here itself. So 2n minus 3 whole factorial. Okay, so now if you observe 3 factorial and 3 factorial can be cancelled, right? So let me erase this one into n minus 3 whole factorial divided by n factorial. So can I write n factorial as n into n minus 1, n minus 2, n minus 3 factorial. So what we are doing, students, we are applying just the definition of factorial notation. So 2n minus 3, 2n minus 3 get cancels, right? N minus 3 factorial, n minus 3 factorial get cancels. So 2n, 2n minus 1, 2n minus 2 whole divided by n into n minus 1, n minus 2, which is equal to 11 by 1. Okay, so now if you observe, can I cancel n and n here? Okay, and in the next step, 2, keep looking at each and every term, students. You will get an idea how to simplify the further steps. Okay, so can I tweak this term as I'll take 2 common, right? So it will be n minus 1 whole divided by n minus 1 into n minus 2, which is equal to 11 by 1. Okay, so let's see on further simplification, what will be the answer. Okay, so what I have done in this part, I have taken 2 common. Okay, so in the next step, this n minus 1 get cancels. So 2 into 2, 4. 4 times of 2n minus 1 whole divided by. So this is cancelled, right? This term is cancelled. So we are left with n minus 2, which is equal to 11 by 1. Okay, so now cross multiply, students. 1 is, right? So 4 times of 2n minus 1 into 1 will be same, which is equal to 11 times of n minus 2, right? 4 2s are 8 minus 4, which is equal to 11n minus 22. Okay, so take the like terms together. So minus 22 shift this side, 22 minus 4, 11n minus 8n. Okay, so 22 minus 4 can be written as 18. So which is equal to, here I can write it as 3, right? So 11n minus 8n. These are like terms, can be subtracted. Okay, so n is equal to 18 by 3, which is equal to 6. So what is our n in the second case? N is equal to 6. Okay, so the other students, so just take this down. So what is the formula for NCR, students? NCR formula is n factorial by r factorial into n minus r factorial. So one of the student is asking, sir, how NC1 is equal to n? Okay, so let's solve this. So just use the formula, right? So what is r here? R is equal to 1. So NC1 is equal to, so n factorial divided by r factorial, students. So what is r here? 1 factorial. Okay, so now next part, n minus r. So n minus 1 whole factorial. So nc1 is equal to n factorial. So 1 factorial will be 1. 1 into n minus 1 factorial will also be, sorry, 1 into n minus 1 factorial will be n minus 1 factorial. Okay, so now use the definition of factorial notation here. So can I write or tweak this n factorial as n into n minus 1 factorial? Okay, so using the applying the factorial notation definition. So divided by n minus 1 factorial, nc1 is equal to, so this get cancels. So hence nc1 is equal to n.